When we hear the word work, we often think about studying, going to a job, or exerting effort. But in physics, work has a very specific meaning. It describes the transfer of energy that occurs when a force causes an object to move over a distance. Mathematically, work is defined by the formula. Work equals force times displacement times the cosine of theta. Let's break this down. W stands for the work done. F is the magnitude of the applied force. D is the magnitude of the object's displacement, meaning how far it moved. And theta is the crucial angle between the direction of the force and the direction of the displacement. It's only the component of the force that acts in the direction of the displacement that does work. The value of work can be positive, negative, or zero, depending entirely on the angle theta. If the force has a component in the same direction as the displacement, meaning theta is less than 90 degrees, the work done is positive. This means the force is adding energy to the object, often increasing its speed. If the force has a component in the opposite direction of the displacement, where theta is greater than 90 degrees, the work done is negative. This force removes energy from the object, often slowing it down. Friction typically does negative work. And finally, if the force is perpendicular to the displacement, meaning theta is exactly 90 degrees, the work done is zero, because cosine of 90 degrees is zero. Also, if there's no displacement, d equals zero, or no force, F equals zero, the work done is zero. A force perpendicular to motion doesn't transfer energy. The standard unit for work in the International System of Units, SI, is the joule, abbreviated as J. 1 joule is defined as the amount of work done when a force of 1 Newton displaces an object by 1 meter in the direction of the force. Let's look at some examples. Pushing a stalled car forward involves positive work because the force you apply is in the direction the car moves. Lifting a weight upwards also involves positive work by the lifting force. When a car brakes, the braking force opposes the car's motion, so it does negative work, removing kinetic energy. Friction acting on a sliding object also does negative work. If you carry a heavy bag horizontally at a constant velocity, the upward force you exert to hold the bag does zero work because the bag's displacement is horizontal perpendicular to the force. Similarly, the gravitational force on a satellite in a stable circular orbit does zero work because the force is always perpendicular to the satellite's instantaneous velocity. So far, we focused on constant forces. But what if the force changes as the object moves, or the path isn't straight? In those cases, we need calculus. The work is found by integrating the dot product of the force vector and the infinitesimal displacement vector along the path. We won't delve deep into this now, but it's important to know this more general definition exists. Crucially, work represents a transfer of energy. When net positive work is done on an object, its kinetic energy increases. When net negative work is done, its kinetic energy decreases. This is known as the work-energy theorem. So, remember, work in physics is force acting over a distance. It's a scalar quantity measured in joules, and the angle between force and displacement determines if the work is positive, negative, or zero.